Usually when we think about the future of artificial intelligence, we picture an app, right?
Yeah, absolutely. Like a sleek interface on your phone or maybe a smarter search engine.
Right, exactly. Or, a voice assistant that finally actually understands context instead of just setting timers. We think of it as software. It's invisible, weightless.
It's just something you download, uh, update, and then basically forget about. We tend to conceptualize AI purely in the digital realm, like it
Yeah.
just lives up in the cloud.
The cloud, which, is a beautiful marketing term, but let's be honest here.
Oh, for sure.
Okay.
The cloud is just a polite, sanitized way of saying your data lives on someone else's computer server,
Mhm.
sitting in a massive, windowless, air-conditioned warehouse somewhere in, like, Virginia or Texas.
Yeah.
It feels immaterial to the end user,
Yeah.
but it's tethered entirely to conventional terrestrial real estate.
But what if that conventional framing is what if it's completely wrong? What if the future of artificial intelligence isn't an app at all?
Well, that's the big question.
Right. What if it's a physical utility? Something delivered from the vacuum of space, built by a heavy industry company whose actual day job is launching massive steel cylinders into orbit.
Now, that is a paradigm shift. I mean, we are talking about intelligence moving from the realm of pure software into the realm of heavy physical infrastructure.
A shift from bits to atoms, basically.
Exactly. The transition from software companies writing clever algorithms to industrial companies literally manufacturing intelligence on assembly lines.
And that massive shift is exactly what we are exploring today. Welcome to the deep dive. For this exploration, we are looking at a truly fascinating, highly analytical piece of writing from a blog called Netizen, dated April 22, 2026.
It's a fantastic piece.
Yeah, it really is. The piece is titled SpaceX plus Cursor, and it includes this deeply speculative accompanying essay called Build, Baby, Build.
And I'll say it's a dense read, but a crucial one, because the source material isn't just reacting to a fleeting news cycle,
Right? It's not just a standard press release.
No, not at all. It's attempting to decode the underlying mechanics of a massive corporate maneuver that the broader market might actually be completely misinterpreting right now.
So here's our mission for today. We aren't just looking at a corporate merger here. We aren't just reading a tech headline. We are unpacking how a strategic partnership between SpaceX specifically via their AI division, XAI, and a highly popular AI coding startup named Cursor might literally reshape the industrial base of human civilization.
It's a huge claim.
It is. The goal here is turning intelligence into something as ubiquitous, as cheap, and as physical as electricity.
And what's really fascinating here is that on the surface, this looks like your standard Silicon Valley software partnership. Tech company A partners with tech company B.
Happens every Tuesday, right?
Right, exactly. But when you look at the players involved, a heavy aerospace manufacturer and a generative AI coding tool, you realize it's anything but standard. The core thesis of the material we are reviewing today is that SpaceX is using this specific deal to orchestrate a massive pivot.
A pivot away from just rockets.
Exactly. They're transitioning from being primarily an aerospace giant into an enterprise AI infrastructure conglomerate.
Okay, let's unpack this because the sheer scale of this April 21 and 22, 2026 announcement is it's hard to wrap your head around. Let's look at the financial architecture the text lays out for this multi-billion-dollar handshake.
Yeah, the numbers are wild.
Because the numbers alone tell a story of sheer aggression.
They really do. The numbers are staggering. And more importantly, the structure of the deal is highly unusual for the technology sector.
Okay, so SpaceX and Cursor are entering this partnership. And Cursor, for context for those who don't know, they build AI tools that help software engineers write code faster and more efficiently.
Right, they're hugely popular with developers.
Yeah. And as part of this deal, SpaceX holds an option to acquire Cursor outright for around $60 billion later in 2026. $60 billion.
Which is a massive valuation.
Massive.
Yeah.
But here's the kicker, the part that literally stopped me in my tracks. If SpaceX ultimately decides not to buy Cursor, they will still pay roughly $10 billion just for the collaborative partnership work they do together in the meantime.
Yeah, a $10 billion walkaway fee, essentially.
It's insane. And in exchange, Cursor gets to plug their software into SpaceX's Colossus supercomputer, which is this monstrous machine loaded with hundreds of thousands of NVIDIA GPUs.
It is a massive flex, both of capital and of raw compute power. It sends a very, very clear signal to the market.
Wait, okay, but a $10 billion non-refundable fee makes zero economic sense to me. Like, if I'm buying a house, I don't give the seller $10 billion just to walk around their living room and see if I like the feng shui.
That's a very fair point.
Right.
Yeah.
If I'm putting a $10 billion engagement ring on a partnership just to see if I even want to get married, what am I actually buying? It can't just be software access.
The engagement ring analogy captures the commitment level perfectly, I think. To understand why a corporate entity structures a deal this way, you have to look at corporate psychology and market positioning.
Okay.
They aren't just buying software. This structure puts a definitive, unmovable deadline and a massive financial floor on the relationship. It proves to the market and to Cursor's leadership that SpaceX wants to own these capabilities fundamentally, not just license them.
Like a standard vendor relationship.
Exactly. Licensing leaves you vulnerable, right? Ownership gives you control.
So it's about controlling the underlying asset.
Yeah.
But why the rush? Why force a $60 billion acquisition option onto the exact timeline for late 2026?
Well, if we connect this to the bigger picture, the source material explicitly ties this aggressive move to SpaceX's widely anticipated 2026 initial public offering.
Oh, the IPO. Right.
Yeah. An IPO is fundamentally an exercise in storytelling. You are pitching Wall Street a narrative about what your company will be worth in 10 years.
Not what it's worth today.
Right. So if you go to Wall Street and say, hey, we launch rockets and we maintain satellites, that's great. It's a solid, high-margin hardware business. But it has single event revenue. You launch a rocket, you get paid once.
And Wall Street historically assigns much lower valuation multiples to hardware companies compared to software companies, right?
Vastly lower. I mean, Boeing or Lockheed Martin might trade at, what, 2 or 3 times their revenue? But software, specifically enterprise software, has recurring revenue.
Subscriptions.
Exactly. It's infinitely scalable without building a new physical product on an assembly line every single time you make a sale. Securing sticky enterprise software revenue diversifies SpaceX's balance sheet fundamentally.
Because once a developer or a whole company starts using an AI tool to write their core code, they almost never rip it out and switch platforms. It's too deeply embedded in their workflow.
Precisely the point. By securing that revenue stream, SpaceX shifts how institutional investors will calculate their valuation multiplier. They stop looking like a traditional aerospace defense contractor, and they start looking like a foundational enterprise tech player.
Yeah.
The goal is to be valued like Microsoft or Amazon Web Services, where multiples could be 10 or 20 times revenue.
Wow. Okay, so Wall Street might completely fall in love with the recurring revenue model, and the financial math certainly justifies a $10 billion risk if it pops their IPO valuation by hundreds of billions.
It's a calculated gamble.
For sure. But the financial numbers only hold up if the underlying technology is genuinely revolutionary. Which brings us to the most obvious question. Why is an AI coding tool specifically worth $60 billion to a company that literally builds rockets and space stations?
Right. That leads us directly into the tech's analysis of what Cursor actually does and why it's arguably the most critical piece of software in the world right now.
The essay Build, Baby Build goes deep on this concept. It argues that the most underrated AI revolution right now isn't, a chatbot passing the medical board exams, and it isn't an AI generating photorealistic deepfake videos.
No, it's something much more structural.
Yeah, the real tectonic revolution is code, because code is the tool that creates all other tools.
Code is the foundational raw material of the modern global economy. Think about it. Every digital interaction you have, every logistical system that routes global shipping containers, every algorithmic trading desk, every piece of software that balances a local power grid, it is all built on code.
All of it.
And historically, to manipulate that material, you needed to learn complex syntax. You had to learn C++ or Python or Rust. You had to learn the rigid, unforgiving language of machines to build anything of value.
So if I can try an analogy here, it sounds like Cursor is essentially acting as a universal translator for creation.
That's a great way to put it.
Like, you don't need to speak the deeply complex, often frustrating syntax of the machine anymore. You just need to have an idea, an architectural vision, and you can explain it in plain English. The AI listens to your intent, understands the logic, and translates it into functional, bug-free architecture.
A universal translator for creation is an exceptionally accurate way to visualize it. And the text discusses this through the concept of the meta layer.
The meta layer.
Yeah, SpaceX isn't looking at Cursor and thinking, great, we have an app we can sell to professional programmers to make them type 10% faster.
Right.
They're looking at this and realizing they're trying to build the AI that builds everything else.
The meta layer. So it's not just a tool,
Yeah.
it's the factory that produces the tools. That is such a massive shift in perspective.
It really is.
Yeah.
And the downstream economic effects mentioned in the source are staggering if you play them out over a 5 or 10-year horizon.
Yeah.
If you lower the barrier to writing complex software from requires a 4-year computer science degree to requires the ability to clearly state your problem and logically verify the output, the entire labor market shifts.
Oh.
The essay specifically points out that visionary entrepreneurs will be able to ship complex, scalable products without needing to hire massive engineering teams.
And the text mentions governments finally being able to modernize their legacy systems faster. Let's be honest, half of the financial sector and government infrastructure runs on COBOL code written in the 1970s.
Oh, absolutely.
Updating that has been an absolute nightmare because nobody speaks the language anymore. But an AI translator solves that overnight.
It does. It democratizes the fundamental act of digital creation. It turns intention directly into execution.
Think about what this means for you, the listener. Imagine a scenario 5 years from now. Let's say you own a small logistics business, maybe a regional delivery fleet. Right now, if you want custom routing software that integrates with your specific payroll and customer database, you have to hire a dev agency, spend hundreds of thousands of dollars, and wait a year.
Easily.
In this future, you just sit down, open your laptop, and have a conversation with an AI. You explain your business logic. You say, I need a system that routes my trucks based on real-time traffic, logs the hours for payroll, and texts the customer when we are 5 minutes away.
And it just builds it.
Yes. The AI generates the entire software suite for you, custom built, for like a $5 monthly subscription. This is about turning millions of ordinary people into engineers overnight.
And that is precisely why a heavy engineering company like SpaceX wants this software. Because a robotic, highly advanced manufacturing company requires mountains of code to operate its own internal systems.
But wait, this vision of millions of people casually generating millions of lines of code, spinning up complex software suites on a Tuesday afternoon, it brings us to a massive physical reality check.
Ah, yes, the physical bottleneck. It is unavoidable.
If SpaceX and Cursor are going to empower millions of people to generate endless amounts of code and run countless AI agents 24/7 to build all this software, they are going to hit a massive physical wall.
A literal wall, yeah.
Where does all the processing power come from to actually run this universal translator at a planetary scale?
Well, the author of the source material emphasizes a hard truth about the industry right now. Every AI company, no matter how elegant their algorithms are, eventually have the compute wall.
The compute wall. Let's break down what that actually means physically.
Okay, so intelligence, in the artificial sense, is entirely constrained by the physical ability to manufacture it. It requires physical servers, highly specialized silicon chips, and massive uninterrupted rivers of electrical energy.
Right.
It is not an infinite digital resource. It is a scarce physical commodity.
Okay, but when I think of massive server farms and infinite compute power, I think of the current giants. I think of Google. I think of Amazon Web Services. I think of Microsoft Azure. Right, because they have been building data centers for 20 years, don't they already do this? Why is SpaceX stepping into this brutal low-margin infrastructure arena, and why is their approach considered different, according to the source?
The source material addresses that exact point using this really brilliant aviation metaphor. It suggests that right now, the AI industry is operating like the very early days of commercial aviation.
How so?
Everyone, OpenAI, Anthropic, Google's DeepMind, they're all competing fiercely to build the best, fastest, most capable airplanes. The airplanes represent the AI models themselves.
Okay, building the planes, pouring billions into making the algorithms smarter.
Right. But SpaceX looks at the entire global landscape and says, we don't just want to build airplanes, we want to build the airports.
Ah, the foundational infrastructure that the planes require to even exist?
Exactly. It highlights a fundamental difference in corporate mindset. A normal software company, even a giant one like Meta or Microsoft, says, we need more processing power to train our next model. Let's buy 100,000 more chips from NVIDIA and rent more real estate to plug them in.
Right, that's the standard playbook.
But SpaceX, driven by its aerospace manufacturing DNA, says, let's build the factory that builds the factory that builds the chips. It is a philosophy of extreme, uncompromising vertical integration.
You know, it reminds me of Henry Ford and the River Rouge plant in the
Oh,
1920s.
that's a good comparison.
Ford didn't just build cars, he bought the iron mines, the rubber plantations, the coal mines. Iron ore went in one end of the factory, and a finished Model T rolled out the other.
A completely closed loop.
Yeah. SpaceX is famous for absorbing their supply chain. If buying a specialized fuel valve for a rocket takes a legacy supplier 6 months, SpaceX just designs the valve in-house and starts milling it themselves by the end of the week. Now they're applying that exact same heavy industry mentality to AI compute infrastructure.
And when you apply heavy industry to AI compute, you run straight into the inescapable laws of thermodynamics.
Oh boy.
The source states it bluntly, actually, and says, AI is heat.
AI is heat. That really strips away all the mystique, doesn't it? It's not a glowing, ethereal brain humming in the ether. It's literally just a small piece of silicon drawing a massive amount of electrical current and getting incredibly hot.
Exactly. When you are running hundreds of thousands of high-performance GPUs to train an AI model, the primary engineering challenge ceases to be software design. The code is almost secondary at that point.
Wow, really?
Yeah. The primary challenge becomes, how do we deliver hundreds of megawatts of continuous power to this facility, and how do we stop the silicon from physically melting under its own thermal load?
Explain the mechanics of that heat, because we aren't just talking about a warm laptop on your knees here.
No, not at all. A single high-end AI processor can draw 700 to 1,000 watts of power. It is essentially a highly sophisticated space heater.
Mm.
Now, put 100,000 of those in a single building. You're generating heat at an industrial, almost incomprehensible scale.
That's terrifying.
If your cooling systems fail for even a few minutes, the hardware destroys itself. Traditional air conditioning just doesn't work at this density. You have to pump literal rivers of chilled liquid directly over the processors.
And this is where SpaceX has a totally unfair advantage compared to a traditional Silicon Valley software company.
Absolutely. This raises an important point about corporate culture and engineering DNA. SpaceX is, at its core, a thermal management and power delivery company. A rocket is essentially a massive, highly controlled explosion.
Right.
Managing intense heat, managing cryogenic fluids, and directing massive amounts of power is their native language.
The text details some of the ways they're attacking this bottleneck, treating data centers not like delicate office buildings with raised floors and sterile lighting, but like modular industrial equipment. It mentions containerized GPU farms.
Yeah. Rather than spending 3 years getting zoning permits to build a custom glass and steel data center, you prefabricate the infrastructure. You take industrial shipping containers, pre-wire them, pre-plumb them for advanced liquid cooling, pack them with dense server racks, and just drop them onto a concrete pad via crane.
And you plug them directly into a power source.
Exactly.
And the power sources they are looking at are completely wild. The text specifically mentions nuclear microreactors and geothermal integration.
The energy requirements for the next generation of AI models are so vast that tapping into the existing municipal power grid is no longer feasible. You will brown out entire cities.
Wow.
The source argues that SpaceX recognizes this constraint. Geothermal integration means literally drilling deep into the Earth's crust to tap into continuous baseline thermal energy to run steam turbines.
And nuclear microreactors. I mean, we are talking about splitting the atom, navigating massive regulatory hurdles, and building private, localized nuclear power plants just to make sure you can ask your AI to write a Python script without the servers crashing.
It sounds like pure science fiction, but it is the grim physical requirement for the scale of intelligence they are trying to produce. The company that solves cooling and power generation at a massive independent scale essentially becomes a global AI superpower by default.
Because they control the foundational physical resource that everyone else is fighting over.
Precisely.
Which leads to a very spicy consequence. By aggressively solving these physical heating and compute problems, and by building their own massive data centers powered by their own energy grids, SpaceX is inadvertently, or perhaps very intentionally, preparing to go to war with the very companies currently supplying their parts.
Which brings us directly to the hardware stack and the potential dismantling of current technology monopolies.
I want to jump straight to the biggest, boldest prediction the author makes here. The text argues that if SpaceX gets truly serious about this vertical integration, NVIDIA's monopoly starts to look incredibly fragile.
That is a massive, highly controversial statement. I mean, NVIDIA is currently one of the most valuable companies in the history of the world, precisely because everyone, Google, Microsoft, Meta, OpenAI, has to buy their chips to participate in the AI boom.
Right.
NVIDIA controls the fundamental choke point.
Wait, if NVIDIA makes the chips everyone needs, and SpaceX is currently buying hundreds of thousands of those chips for their Colossus supercomputer, how is SpaceX a threat? Is SpaceX merely using NVIDIA chips to train their current models while simultaneously designing their own silicon to eventually replace NVIDIA?
You've identified the exact mechanism of the threat. To understand how fragile the monopoly might be, we have to look at the current supply chain dependency.
Okay, lay it out.
It flows like this. NVIDIA designs the chips.
Yep.
Fabrication plants in Taiwan physically build them. AI labs like OpenAI buy those chips to train their massive models. Then, independent app developers use those models via APIs to build consumer software.
Right.
And finally, consumers use the apps. Everyone is entirely dependent on the layer below them.
It's a vertical chain of dependencies, and NVIDIA sits at the very root, taxing everything built above it.
But the text predicts SpaceX could flip this entire fragmented structure on its head. Instead of relying on a dozen different vendors across the supply chain, the SpaceX model becomes a closed sovereign loop.
The closed loop.
Yes, SpaceX builds its own custom compute clusters and custom silicon chips. Those chips power SpaceX's proprietary AI models. Those models are integrated with their own software tools like Cursor. And all of it is pushed through SpaceX's own physical distribution network directly to the end consumer.
Custom chips, that's the pivot point.
Yeah.
Explain the difference between what NVIDIA sells and what SpaceX might want to build.
It comes down to the difference between training an AI and running inference. Training an AI is like sending a massive neural network to a grueling university for years, forcing it to read the entire internet. It requires colossal, generalized computing power, which is what NVIDIA excels at making.
Got it.
Inference, on the other hand, is the AI taking the final exam. The model is already trained. It just needs to answer a specific prompt or analyze a sensor reading.
And inference doesn't require a massive supercomputer.
Exactly. Inference can happen on a much smaller, highly specialized chip. The author argues that custom silicon is the rational, inevitable next step for a company where, quoting the text here, every gram matters and every thermal fluctuation matters.
Right, because of space.
Yes. If you are trying to put AI inference hardware on a satellite orbiting in the vacuum of space or inside the robotic arm of a manufacturing drone, an off-the-shelf, power-hungry NVIDIA GPU is completely useless. It's too heavy, it draws too much power, and it generates too much heat.
You need highly specialized embedded inference chips designed specifically for your own architecture. Here's where it gets really interesting for me. The author zooms out and looks at this theoretical, fully integrated stack. They argue this deal isn't just a software partnership. It's the blueprint for a totally unprecedented kind of corporate conglomerate.
It really is.
The text literally says this future SpaceX architecture looks like, and I quote, AWS plus NVIDIA plus Tesla plus OpenAI plus Boeing plus Verizon rolled into one.
It's a breathtaking combination of capabilities. It aggregates industries that have historically remained completely distinct.
And for you, the listener, I really want you to pause and consider the personal implications of this consolidation. Think about your monthly tech ecosystem right now.
Yeah, map it out.
You pay a cloud storage bill to Apple or Google. You pay an internet service provider like Comcast or AT&T. You pay monthly subscriptions for various software apps. You buy physical hardware from Dell or Samsung. What happens to your tech life when a single mega company owns all the layers?
The text outlines those layers very clearly, referring to it as the new stack.
Let's hear it.
Layer 1 is compute, the custom chips, the nuclear-powered data centers. Layer 2 is connectivity, the satellites. Layer 3 is the AI models themselves. Layer 4 is the tools, like Cursor, that let you build upon the models. Layer 5 is distribution, the user interfaces and access points. And Layer 6 is embedded AI, the physical robots, cars, and airspace vehicles that act on the intelligence in the real world.
Wow. If one entity controls the stack from the silicon buried in the ground to the satellite orbiting in the sky to the software running on your screen, that is an unprecedented level of leverage over the global economy.
It is the ultimate realization of infrastructural dominance. But, as the text astutely notes, creating the ultimate AI stack, even a perfectly vertically integrated one, is essentially useless if it's trapped in a server farm in Texas.
Right.
Intelligence, to be valuable, has to travel.
Yeah, you can build the smartest, most capable artificial brain in the history of the world, but if it has no nervous system to communicate with the rest of the body, it doesn't matter. It's just a giant heating element in a warehouse. How does this mega conglomerate deliver this unprecedented level of intelligence to the rest of the world?
This leads us to what is perhaps the most unique, unreplicable asset SpaceX brings to the table: And it's not rockets. It's Starlink.
Let's dive deep into Starlink, because the source material makes a crucial point that I think most people, myself included, usually miss. We casually refer to Starlink as satellite internet.
Right, like it's just broadband.
Exactly. We think of it as a convenient way for RV owners to watch Netflix off the grid. But the text argues that calling it satellite internet is a massive underestimation. Starlink isn't just rural broadband. Starlink is reach.
Reach. That is the critical differentiator. To understand the geopolitical and economic power of reach, we have to look at how traditional cloud computing distribution actually works.
Let me try to visualize this. The traditional cloud model, like the AWS or Google Cloud model, feels like a highly advanced municipal piped water system.
That's a good analogy.
It's incredibly efficient, but it relies entirely on laying physical pipes. Massive underwater fiber optic cables, digging trenches across continents, laying copper wire to individual homes.
Very expensive. Very slow.
Right. And practically speaking, because of the immense capital cost, those pipes only reach wealthy neighborhoods, dense urban centers, and developed nations. If you live outside the pipe network, in rural Africa, in the middle of the Pacific Ocean, or in a war zone, you don't get the water. You don't get the fast internet, which means you don't get access to the advanced AI. You are locked out of the intelligence economy.
That is an excellent visualization of the limitations of terrestrial infrastructure. It is inherently unequal. Starlink, combined with AI, fundamentally changes the physics of distribution. Well, using your analogy, if the traditional cloud is a piped water system, Starlink is like controlling the weather and making it rain globally. It doesn't matter if you have pipes laid down. The resource falls from the sky everywhere on Earth simultaneously.
Making it rain globally. I love that. And the text connects this global reach to something called the feedback loop. Can you unpack how owning the distribution layer actually supercharges the AI models themselves? Because it's not just about delivering the product, it's about making the product smarter.
Absolutely. In the field of artificial intelligence, the most valuable asset isn't just having a smart initial model. The true competitive advantage is your rate of iteration. How fast can you learn and improve?
Right.
The text describes the feedback loop as a continuous cycle. You build the model, you deploy it to millions of users, you collect real-world edge case data on how they use it, what questions they ask, and where the model hallucinates or fails.
Okay.
You improve the model based on that massive data influx, and then you redeploy the smarter version.
Build, deploy, collect, improve, redeploy.
Now, most AI companies are severely bottlenecked in this loop because they have to negotiate with middlemen.
Ah, the gatekeepers.
Yes. To get their app to users, they have to navigate the Apple App Store or Google Play. They rely on local internet service providers for speed. They use APIs, application programming interfaces, which are essentially digital waiters taking data back and forth between different software systems, and those APIs add latency.
Or the provider might suddenly raise the price or throttle the connection.
Exactly. Every step in the traditional supply chain introduces friction.
But because SpaceX owns the physical satellites and the ground terminals, they bypass the platform gatekeepers entirely. They don't need Apple's permission. They don't need a local telecom's permission.
They deliver the intelligence direct to user anywhere on Earth with zero intermediaries. This creates a brutally fast iteration cycle. They can push an update to an AI model running on a terminal in the Amazon rainforest and collect telemetry data instantly.
That's what?
They can improve their models at a speed that companies relying on third-party terrestrial infrastructure simply cannot mathematically match.
And the economic implications of this global reach are where the text gets almost utopian, honestly. It discusses the concept of democratization through price collapse.
Price collapse is a very specific, aggressive economic strategy. And it is the defining strategy that SpaceX has mastered over the last 2 decades.
The text points out that SpaceX didn't bankrupt the legacy aerospace industry by building aesthetically prettier rockets, or even necessarily by inventing entirely new combustion physics.
No, not at all.
They won by making rockets relentlessly, unapologetically cheaper. They collapsed the cost curve of getting a kilogram of mass into low Earth orbit through reusability. Instead of throwing a $100 million rocket into the ocean after one flight, they land it and fly it again.
And now, the text argues, they're preparing to apply that exact same cost collapse methodology to intelligence.
The vision laid out here is incredible. It calls it economic liberation. We aren't just talking about your premium AI subscription dropping from $20 a month to $5 a month, although, That would be nice for our wallets.
Exactly.
But the text envisions a world where the fundamental cost of inference, the compute cost of asking an AI a complex question or generating a piece of software drops by a factor of 10 or maybe a factor of 100.
What's truly fascinating is the specific, tangible examples the author uses to illustrate this impending global abundance.
Mhm.
We are talking about delivering high-end cognitive capabilities to populations that have been historically ignored by Silicon Valley.
Right.
Imagine personalized AI tutors operating in rural villages where human teachers simply don't exist, capable of teaching advanced mathematics in the local dialect.
Or highly advanced AI diagnostic systems available in remote areas without clinics, capable of analyzing symptoms and recommending treatments based on the latest global medical literature.
AI legal advisors for populations where access to human courts is prohibitively expensive or corrupt. AI agricultural assistance for subsistence farmers, analyzing soil conditions via smartphone cameras and satellite weather data to optimize crop yields.
But importantly, the text notes this requires localized language support and offline-capable models bundled directly into the Starlink hardware. You can't rely on a stable ping to a server in Virginia if you are in the Himalayas.
Thank you, Kat.
The intelligence has to live locally on the device, updated periodically from the sky. It's about delivering high-end capability to the billions of people who have been historically locked out of the high-scale productivity loop.
It is framed not as charity, but as aggressive global distribution. It's treating intelligence as a fundamental human utility, like access to clean water.
But this utility isn't just for interacting with humans via a screen. Intelligence is going to seep into the physical world.
Yes, this raises one of the most profound questions in the text. What happens when AI steps out of the chatbot interface, out of the browser window, and into the physical environment?
AI is not supposed to live inside a laptop. I highlighted that sentence in the text because it completely shatters how we currently view the technology. We think of AI as a conversational partner, but AI as a physical operator is a totally different ballgame.
SpaceX is uniquely positioned to manifest this reality because, as the text astutely observes, SpaceX already operates like a robotic civilization.
A robotic civilization, that's a strong phrase.
Think about what goes on inside their manufacturing facilities in Boca Chica or Hawthorne. You have vast automated factories, precision manufacturing operating at microscopic tolerances, autonomous monitoring systems evaluating telemetry from thousands of sensors in real time,
Right.
predictive maintenance algorithms identifying metal fatigue before a part ever fails.
They're operating in environments where a rounding error in a line of code doesn't mean a website crashes. A rounding error means a multi-million-dollar vehicle explodes on a launch pad.
Exactly. High risk, zero tolerance engineering. So let's tie this back to the Cursor acquisition. If Cursor's AI coding tools dramatically explode engineering productivity, allowing one software engineer to do the work of 10, what happens inside the walls of SpaceX?
The machine that builds the rockets gets vastly smarter and faster.
Precisely. You get unprecedented iteration cycles. You get AI-assisted materials engineering, where the software isn't just writing code, it's simulating fluid dynamics and predicting how a newly invented metallic alloy will perform under the thermal stress of atmospheric reentry before the metal's even poured in the foundry.
That's wild.
You get autonomous quality assurance systems that can inspect 1 million welds across a Starship hull in seconds. SpaceX doesn't just build rockets, they build the factory that builds the rockets. And AI is the ultimate frictionless lubricant for that factory.
Once they perfect that highly intelligent, automated industrial machine for their own rockets, that becomes the template for modernizing every other heavy industry on Earth. Construction, mining, global shipping, it all gets rewritten by AI operating in the physical world.
Absolutely.
Yeah, the text doesn't stop at Earth, does it?
No, it really doesn't. It takes the logic of infrastructure and extends it directly into orbit.
This is where the text gets gloriously sci-fi, but grounds it strictly in the economic reality of this $60 billion play. The text mentions orbital AI data centers.
Computing in the vacuum of space.
Yes, literally launching server farms into orbit with laser satellite backhaul communicating directly with Starlink terminals on the ground.
I mean, we were just talking about the massive thermodynamics problem of data centers on Earth, how AI is heat, and how we have to pump rivers of water to cool them down. Space is incredibly cold. It's a near absolute vacuum.
Space provides a unique thermal environment, certainly, though it's complex.
How so?
Well, in a vacuum, you can't use convective cooling. You can't just blow air over a heatsink because there is no air. You have to use massive radiators to bleed heat away via radiation. The engineering challenges of radiation shielding from solar flares and generating megawatts of power in orbit via massive solar arrays are immense.
Okay, so it's not easy. Not at all. However, if any company has the capacity to launch the sheer physical mass required to build an orbital data center, it is SpaceX, with their massive, fully reusable, super heavy lift vehicles.
Think about the geopolitical and regulatory implications of that. It fundamentally reshapes how global AI compute is provisioned.
Oh, completely.
If your data center is in orbit, you aren't tied to the terrestrial power grid. You aren't arguing with local city councils about zoning laws or water usage for your cooling towers. Your data center is sovereign territory, orbiting the planet at 17,000 miles an hour, powered entirely by pure, unadulterated solar energy.
It is the ultimate infrastructural high ground. It removes AI from the constraints of terrestrial geography entirely.
Okay, so we've seen how this mega merger changes everything from off-grid farming to literal space stations. We've talked about custom silicon, global reach, and robotic factories. But what does this mean for the rest of the tech industry?
Ah, the fallout.
Right. The Googles, the Microsofts, the OpenAIs, the Amazons, because they aren't just going to sit back and watch this behemoth eat the world, right?
They absolutely will not. Which brings us to the final analytical phase of the source material, the M&A domino effect and the return of vertical integration.
So put yourself in the shoes of a tech CEO. I'm Google, or I'm Sam Altman at OpenAI. I see SpaceX drop a potential $60 billion to buy Cursor, integrate it deeply with their massive Colossus supercomputer, and start beaming the results down globally via Starlink.
Okay.
I see them building the factory that builds the factory. Do I just shrug, hold a press conference about my new chatbot, and keep doing what I'm doing?
Panic is a much more likely response.
I bet.
The text predicts this deal will act as a massive structural catalyst, triggering what it calls the M&A domino effect, mergers and acquisitions on a mega scale.
The source compares it to the historical inflection points when Meta bought Instagram, or when Microsoft bought GitHub to secure developer loyalty. But the scale here is exponentially larger.
Because the underlying logic of the entire technology industry is violently shifting. For the last 20 years, as the text points out, the internet and mobile era rewarded extreme specialization. It made perfect economic sense to be a company that only designed chips, or only did cloud hosting, or only built consumer apps.
Stay in your lane, perfect your one specific thing, and connect with everyone else via APIs.
That was the playbook.
Yeah.
But AI is reversing that logic entirely. In the AI era, specialization is a profound vulnerability.
Why is that?
Because if you only build models, but you don't own the chips, you can be squeezed on price. If you own the chips, but you don't own the distribution network, you can be shut out of the consumer market. The winner in this new era is the entity that can iterate the fastest at the lowest compute cost with the widest frictionless distribution.
You can only achieve that through vertical integration,
Exactly.
owning the whole pipeline from the silicon mine to the space station. So what does this panic look like practically across the rest of Silicon Valley?
The author outlines a predicted industry scramble that will redefine corporate structures. If SpaceX successfully establishes this vertically integrated sovereign model, competitors will be forced to try and frantically replicate it through massive acquisitions.
A buying frenzy.
Yeah, we will see traditional cloud providers desperately trying to buy up specialized AI application layers. We will see pure AI research labs trying to acquire custom chip startups so they aren't entirely beholden to NVIDIA's pricing power. We might even see legacy telecom companies trying to buy AI distribution tools to make their dumb pipes smart.
The SpaceX Cursor deal is the signal flare in the night sky. It tells everyone that the era of fragmented AI, where everyone just plays nice, stays in their lane, and rents infrastructure from each other, is permanently ending. It's time to own or be owned.
And it's not just corporate entities that will be moving, it's the human capital as well. The text highlights a crucial, often overlooked detail about talent migration.
What's that?
It notes that Cursor's leadership and elite engineering talent have already started bleeding over into SpaceX and XAI teams.
Ah, the brain drain.
Exactly. Historically, for the last several decades, the best, most ambitious software engineers went to pure software labs in Silicon Valley. They went to Google, Meta, or shiny new startups.
Right, that was the dream.
But this deal signals a massive cultural and professional shift. Elite AI engineering talent is actively moving away from standard, screen-based software companies and moving into heavy aerospace, robotics, and industrial manufacturing companies.
Because the frontier has moved.
Exactly. That flips traditional tech recruitment completely on its head. The smartest minds don't just want to optimize ad-click algorithms anymore. They want to work where the massive compute clusters are and where the physical impact on the real world is greatest. They want to build the robotic civilization.
Which perfectly sets up our final thoughts here. Let's zoom all the way out. What does this all mean for you, the listener? We started this deep dive looking at what seemed like a dry, albeit wildly expensive, corporate buyout option.
Yeah, $60 billion check.
Right. SpaceX might buy a coding startup. But as we've unpacked layer by layer, it is so much more than a corporate logo swap.
It is the industrialization of intelligence. We are witnessing the precise historical moment when AI stops being a luxury product, a novelty you play with in a browser window, and becomes a foundational physical industrial utility.
Just like the electrical grid in the 20th century, electricity didn't change the world because a glowing light bulb was a cool parlor trick. It changed the world because it became cheap, hyper-reliable, and embedded into the physical architecture of absolutely everything we touch.
That is the ultimate world-shaping trajectory mapped out in this text. But I want to leave you with a final lingering thought, drawing on the conclusion of the Build, Baby, Build essay, but pushing the implications one step further into our daily lives.
Let's hear it.
The author describes this massive integration of SpaceX's industrial might and AI capability as a private sector Manhattan project aimed not at destruction, but at capability. They envision a near future where intelligence is literally mass-produced in factories. But let's assume they succeed. Let's assume SpaceX, or a conglomerate like them, successfully navigates the thermodynamics, the orbital logistics, and the custom silicon challenges.
Okay.
Let's assume they make AI as cheap, as ubiquitous, and as accessible as tap water, raining down globally from thousands of Starlink satellites.
Okay, assuming we reach that state of total intelligence abundance, where anyone, anywhere can generate complex software for pennies.
If the cost of world-class engineering, coding, and logical problem-solving drops to virtually zero, then technology is no longer the bottleneck for human progress. For the first time in human history, the physical tool will not limit the builder.
Oh, man.
Which raises an incredible, almost intimidating question for all of us. When the barrier to creation is completely removed, the ultimate bottleneck won't be compute power or venture capital or knowing how to write Python syntax.
When what is it?
The ultimate bottleneck will be our own human imagination. When the intelligence to build absolutely anything is practically free, what will you choose to build?
What an incredible thought to end on. The physical and financial constraints of our current technological era are breaking apart, and the landscape ahead is entirely up to what we can imagine and articulate. Thank you so much for joining us on this deep dive. We hope you found some clarity in the complex mechanics of the future, and we warmly invite you back for our next exploration. Until then, keep wondering and keep building.